All right, good to go. Cool. So, good morning. Hope everyone's doing well. I want to go over ODP 409 and then I want to talk about the midterm. But any questions before we get started on that? Questions on 408 or anything else? All right, let's talk about ODP 409. 409 is exactly like 408, except it does lots of error checking. So ODP 408, you wrote a program that took a command line argument, printed its square root. ODP 409 does the same thing, but you can't assume that the argument is correct. So there's a number of ways that this program could go wrong. You might run it with something other than one command line argument. In other words, you might not have a number on the command line at all, or you might have extra entries, extra arguments, okay? So you want to make sure that there's exactly one command line argument, okay? If there's not exactly one command line argument, print an error message, ERR, followed by a new line and exit, okay? So it's got to be exactly that invocation, one command line argument. Assuming that there is exactly one argument, it has to be a valid double precision number. Okay, and it's got to be exactly a double precision number. It can't be a number followed by something like 23 ha or 2.3x. So you're going to scan it with that %LF followed by a %S, that trick that we talked about a few weeks ago. If it's not a valid double precision number, print INV followed by a new line and exit. If you get through those two checks, you've had exactly one argument on the command line and it is a valid double precision number. Now you have to make sure it's not negative, because you can't take the square root of a negative. So it has to be bigger than or equal to 0. If it's bigger than or equal to 0, you're fine. If it's less than 0, print negative NEG followed by a new line and exit. If you make it through all three of those, then what happens? You can print the square root of the number. So now you just do ODP 408, print the square root as a %LF, followed by a new line and exit. All right, and there's a sample program that you can use to see exactly what this should do. So let's run /temp/s1 public. If you run it with no arguments, it should just say ERR. Okay. Now the output that you see here in parentheses, that's not stuff that your program should print. Okay. You should just print ERR, new line, and exit. Okay. But this program is telling you why it's printing that, right? So it detected an incorrect number of arguments. If you say 2, 3, 4, incorrect number of arguments, it should just print ERR. All right. If you have exactly one argument, it should print its square root, and you're done. If you have a negative argument, it should print out negative. If you have an argument but it's not a valid double precision number, it should print out invalid, including if you do 23G or 23.3.3, right? But if it is a valid double precision number, that should be fine. And use scanf, right? Scanf will pick up 0x10 as a valid double precision number. It's hexadecimal 10, which is decimal 16. Prints the square root as 4. All right, so use scanf. All right, so how do we do this? Same thing as 408, but you got to do some error checking. All right, so let's flowchart this. Start your program. Absolute first thing you have to do, right? We need to know if the arguments are negative. We need to know if they're valid numbers. We need to know if they're present or not, right? The order in which you ask those questions is really important. All right, hold on, I gotta check something here. All right, the order in which you ask those questions is important. So, is it negative? Is it a float? Is there exactly one argument, right? I can't check to see if my number is negative until I know that it's a number. It wouldn't make sense, right? How would I check my number to see if it's negative or non-negative if I don't even know if I have a number yet? And how can I check to see if my argument represents a number if I don't know that I have an argument? If there's no arguments, what am I going to possibly compare through scanf to see if it's an actual floating point number? So there's a logical order for doing these things, and conveniently, the order in which you need to do these things is the order in which these conditions are spelled out. Now, that may not always be the case, okay? But thinking through this, right, if you don't have an argument, it makes no sense to say, is that argument a double precision number? And if the argument's not a double precision number, it makes no sense to say, is that number negative? Okay, so flowcharts, don't get a lot of press in computer science courses anymore. They predate computer science by quite a bit, but they still have a use for kind of organizing our thoughts sometimes. So what might we do in the beginning of our program? Check your argument count. Make sure your argument count is 2. Remember, in C, if argc is 2, you have one command line argument plus the name of the program itself. So that's where the 2 comes from. Okay, so is argc equal to 2? If it's not, we're done. I'm just going to say error. All right, which means, print out an error message and exit. Did we print an error message? Yes. Print out the appropriate error message and exit. Okay, if argc is 2, see if scanf returns 1. Remember, we're going to do our scanf with this %lf followed by a %s. And then your first argument is whatever it is that you want to scan that float into, and your second argument is just a character array to hold extra stuff. All right, how do we know if the value that we had in this string, this argv bracket 1, how do we know if it's a valid float? Okay. See if scanf is equal to 1 or not equal to 1. If it's equal to 1, then your argument was a valid double precision number. If it's not equal to 1, it's not valid. And again, this is the only way to check the return value from scanf, the only reasonable way. You may be tempted to say, if scanf returns 2, it's not valid, otherwise it's valid. That's not going to work, okay? You won't get full points for that. There are test cases that will make that break, okay? If it returns 1, it's valid. If it returns something other than 1, it's not valid. All right, so if you're getting 20 out of 30 and you can't figure out why, make sure you're looking at scanf correctly. All right, so if I wanted to parse 2 things, I would check to see if scanf returned 2 or didn't return 2. If I want to parse 5 things, see if scanf returns 5 or something different from 5. All right. The difference is that if I don't have a valid input, scanf might return 2, it might return 0, it might return -1. Okay, there's a lot of possibilities. But if I have exactly one floating point and nothing else, it'll return 1. All right. So see if scanf returns 1. If not, then we got an error. If it returns 1, we had a floating point number. What do we have to check? Make sure that it's not negative. Now 0 is allowed. Positives are allowed. Negatives are not. So is it bigger than or equal to 0? If not, that's an error. If it's positive, print the square root of the number, and we're done. Alright, there's your ODP. And like I say, it might feel like overkill or silly to write a flowchart for something that's really only going to be 4 or 5 lines of code. But this is about organizing, right? It's about thinking about how the steps are performed before you get down into the ampersands and the asterisks and the equal and the brackets and all of that stuff, right? This also tells me kind of that, my program is going to be kind of linear. I'm not going to have a whole lot of deep nesting going on, right? Now, if I just start coding this, I might find, brackets inside brackets inside brackets. But looking at it like this, it's do this, do this, do this, do this, do this. All right, we'll talk about coding styles in a bit. Let's see, question. If the string that scanf detects is larger than the extra array, is it automatically truncated before it's stored in the extra? No, so this is a potential security issue, right? There's nothing to limit how many characters scanf will try to store in this array. So if you're worried about it, you need to make sure that the thing that you're scanning doesn't get larger than the size of this. So what do? You check the string length of argv bracket 1. If it's smaller than the size of this, you're fine. If it's bigger than the size of this, just throw an null terminator in somewhere to truncate it. And then you're guaranteed no matter what's in that string, right, it's not going to scan more than what's in there. But we don't worry about that, okay? That's an edge case. If you're using fgets in scanf, right, just make sure that the buffer that you used for fgets is not bigger than the buffer that you're using for the overflow. And then you're totally fine. Dealing with argvs are always a little bit potentially tricky, right? If I just string copy argv into an array, I need to make sure I have enough space for that, that destination. So argvs take a little bit of special handling in general. Let's see, another question. Why does a semicolon on a command line start running shell commands? So semicolon is a way to separate arguments on the command line. So you can say like print working directory date echo hello, and it'll do all 3 of those things. Right, and so if you type program name semicolon A semicolon B, it's trying to run each of those commands. So so it's really just like typing in those commands on separate lines, one after the other. And that message about bash is just bash saying it doesn't know those commands. All right, so that's the ODP. Any questions about that? Write it up, compile it, assess it. And when you assess, remember the general structure of the assess command is like this. Assess, followed by the name of the executable program that you want to run through the assessment system, followed by the name of the source code file. And right now, ODP 409 is live, so it's always going to assess for ODP 409. Doesn't matter what these files are called. Okay, these are just files named. This is the program that's going to be executed in the assessment system. This is the source code that's going to be loaded for human review. So, my recommendation, call your source code ODP409.c, and then call your executable ODP409. Don't forget your -lm for this one. And then when you assess, it's ODP409 is the executable, ODP409.c is the source code. And now when I do ODP420, what am I going to do? I'm going to call it 420.c. I'm going to compile it like this. I'm going to assess it like that. Habits are your friend, right? Programming is a lot about habits. If you have to stop and think really hard about what did I name this thing and what do I call the executable and how do I run it, right? That's spending energy somewhere where you don't necessarily want to be spending it. So get in the habit of making habits. It's a good general guideline. All right, other questions, comments? All right, let's talk about the midterm and such. So my attempt to unlock people's answers yesterday didn't work, but we figured it out in the morning section. So if you can't see your answers on the midterm, reload Canvas and check again. They should be accessible at this point. So let me make some general comments and observations, and then we'll go through the specific questions. But let's talk about some generalities. So there was a variety of scores on the midterm. The average was around 60. Okay, so that's the first thing. If you scored 50, 60, you're kind of in the ballpark of the class average. All right. There were some very high scores, and then there's some people who didn't show up. So first thing, most important thing, I don't want people to panic over this. Okay, if you underperformed, if you came into this course thinking, I understand C, I did well in 121, this shouldn't be a problem, and you were alarmed by the midterm and by the score you got on it, right? I want you to take that seriously. Don't write it off as a fluke. I want you to take that as, I should do something differently, okay? But I don't want you to panic. I don't want you to think, I ran the numbers and there's no way I can pass the course and I'm going to be here another year and all that kind of stuff, okay? Nothing is set in stone. A lot of people stumble on the midterm and then course correct, and by the time they get to the final exam, they're doing really solid work and they can demonstrate on the final they understand the essentials of the course, right? You're good to move on to 222. So there's curving that takes place usually at the end of the course. The most important thing at this point, if you feel like you underperformed on the midterm, the most important thing is to figure out how to course correct, okay? How to change what you're doing or what else you should be doing to try to make sure that you get on top of whatever the issues are, okay? And this is something we can talk about one-on-one in office hours or email. But some general comments here that may be helpful. Testing in a programming course is kind of weird because it's trying to write stuff on paper or in an editor without the benefit of a compiler, without the benefit of other resources, and that's a little bit artificial, right? But it's a way to assess something. But that can be kind of daunting. It can be stressful, and especially when it's a timed test, which these exams are. It's not necessarily the best measure of someone's understanding of programming or Linux or Bash. So what can you do? Practice, right? As you're writing code, particularly things like ODPs, try to write them on paper, right? Try to figure out what they are going to do and try to write code that is as close to perfect the first time. Okay? That's a high bar. And there's always going to be, you know, missing semicolon or an extra curly bracket or something like that. Those are inevitable, okay? I'm startled when I write a piece of code and it works the first time, even if it's only 10 lines. But the basic flow of a program, the basic logic, the basic structure, if you can nail that down, right, first time through, that's really good practice for exams, okay? Because that's basically what you're doing on these tests. And, you know, on your programming assignments, if you're missing a semicolon, if you misspelled INT or something, you know, that's not a big deal. I'm looking for things that, you know, you should have written, you know, 1,000 times in your life, like, you know, int main parentheses, int argc, comma char star star argv, close parentheses, opening curly bracket. That's going to become, you know, something that you just say in your sleep at some point. But general program flow, algorithms, basic loop structure, things like running sums, things like iterators, stuff like that, those will become more and more second nature the more you write them. So suggestions, right? Again, work with a plain editor, VI, Nano, something like that. Stay as far away from IDEs as you can. They are not your friend, okay? If you're getting paid, you know, per line of code or per hour or per project completion, and you need to crank out code as quickly as possible, yeah, go to IntelliJ, go to Visual Studio, something like that. If you're trying to learn a language, get as far away from IDEs as possible. They will not help you learn. Why? Because they write code for you. That's why they're so good when you're working in a production environment and you need to be efficient. But you don't want code written for you when you're trying to learn how to write code. It just makes no sense. Personal preference. I would stay away from auto-indentation. Okay? People have a lot of trouble with indenting code. People have a lot of trouble with brackets. How many times have you had this experience? You write your code, you compile it, and you get an error message, and you look, and the error message is a curly bracket. And now you say, oh, I wonder if this is extra, or maybe I need an extra one. So you put an extra curly bracket in, and you run, you still get a message, so you delete it, and you delete the other one, and now you don't get your error message. But you run your code, and it's not working right, right? This is not the way to write code that will make sense to you, right? Curly brackets should never be a mystery. So curly brackets are related to nesting, right? You have a function, and inside that function you have a for loop, and inside that for loop you have an if statement, and as part of that if statement you have an else clause, right? You're nested really deeply inside your logic. If you're indenting by hand, that process of indenting, right, that conscious act of indenting is another way for your brain to sort of keep track of where it is in the bigger picture. Now visually you can see that you're indented, right? But you know, if you actually do the indenting, you're engaging your muscles, you've got another modality reinforcing what's going on. As opposed to an editor that's indenting for you, and now you're trying to make peace with this piece of software, right? You're typing the statements of your else clause and you're done, and now what? You know, now I've got a bunch of brackets sitting here, but I don't know which bracket goes to which, so I have to go back up and look to see where this bracket goes, and so on and so forth. So just things to think about, right? Try indenting code by yourself. Try putting in your closing brackets by yourself, and see if it helps you make more sense out of why you're indented a certain amount, because it's directly related to nesting. right? And one of the biggest problems that I see students running into is understanding their nesting level, especially at the end of nested blocks, right? You're done with your else statement. How many closing brackets do you want? Well, you want one for the else, which was part of the if. You want another for the for. You want another for the function itself. Do I need a fourth one? I don't know. So play around with that, okay? The other general comment, there's this notion of 10,000 hours, right? It's kind of a rule of thumb. It's more of an observation that a lot of people who are really skilled at something, typically 10,000 hours to get to that level of expertise, okay? 10,000 hours to reach a high level of proficiency in playing drums or woodworking or something else. So another rule of thumb, ideal circumstances, for every hour you spend in class, you should plan on 3 to 5 hours outside of class. Okay, this is absolutely not feasible for most people, because if you got 3 hours of class a day, that would be 15 hours outside of class. That's 18 hours. You got 6 hours left to eat, sleep, and live your life. But it's something to keep in mind, right? And at the very least, you should be spending some amount of time outside of class every day. And what should you be doing? Not watching videos on how to program, not listening to me talk about how to program, not reading web pages about how to program. You should be writing code, okay? That is the way to get better at writing code. And it sounds kind of, silly in kind of a self-referential way. The way you get better at coding is by coding. So there's ODPs, which are hopefully giving you daily practice on coding, and I'm going to try to keep those up going forward. I can give you sample problems. I can point you to websites that just have, page after page of sample problems to code. If you have something that you're interested in working on, something that's, that you're curious about, that you can spend time coding, that's a really good way to practice. You can get into game design without too much code sometimes. You kind of need to get a little object-y, so that might have to wait, but something that appeals to you to get you to sit down and start writing code every day. And the more you code, the better you're going to be at coding. Now, if you spend 3 hours a day outside of class writing code, and you do that 7 days a week, that's about 20 hours a week. That's about 1,000 hours a year. That's 10 years to get to your 10,000 hours. That's 3 hours a day, right? Which sounds like a lot. 3 hours a day, you're still 10 years to get to 10,000 hours. And that's another rule of thumb you hear sometimes in the industry, 10 years to get to a high level of proficiency in coding. And especially with our current situation in a pandemic, right? A lot of us are raising children and taking care of parents and things like this on a daily basis throughout the day, right? Helping our kids do their schoolwork and get online and deal with technology issues with their schools and so on. So I understand, time is really limited. And I understand everyone here is taking lots of courses that have lots of demands on your time as well. And we need time to live, right? Especially now, we need time to just sit back with headphones and listen to music or go out for a walk. But if you can make time to write code, do it, okay? And the more you can do that, the better off you're going to be. And if you need suggestions for things to work on or pointers to websites with sample problems, let me know, right? And I'll give you some ideas. And that will help you on exams, right? If you can sit down, if you've written 100 main programs during the quarter, and then you get to an exam that says write a main program, you don't even have to think about int main parentheses in argc comma char star argv close paren opening curly bracket integer I semicolon. It's just going to flow, right? It's the thing that you do. So someone asked, I don't know those sites in particular, LeetCode or Hacker Rank, but there is a Project Euler, which some people like. Those are fairly large challenges to take on. W3 Resource, I think, is another one that has just, you can pick a language and there's just tons of problems. And you can pick sections for C and it'll be, introductory concepts, arrays, strings, arithmetic, looping, conditionals, and it's just, just little problems. Write something which reads two numbers, prints the sum of the integers between them. Stuff like that. All right, so that's kind of a general thing to keep in mind. And like I say, I totally understand that we're not in ideal circumstances. I was super, super lucky when I was in school. That was all I was doing. I taught, I TA'd to make some extra money, but that meant, I was sitting around coding. And my friends and I, we sat around and we coded. And that was pretty much it. And the only thing that got in the way was going to classes. So you go to physics and you do your lab and you come back and then you code some more, right? And that's exceptionally lucky. And most people don't have that situation today. It's just not possible. I mean, we're working as students and taking care of other people and so on. So, but whatever you can do will help, okay? The more time you can spend coding, the more that will help. And if you have, a fortunate open afternoon, and you can spend the time, spend a few hours getting your head deep into something, right? And writing code, it'll all pay off down the road. All right, so let's look at specifics. So midterm. So open book, open note. Ideally, people were not using any other resources other than an editor. So if you were on the server to get VI access, that was okay, but I didn't want people trying out Unix commands. I didn't want people, compiling code, things like that. And the reminder up here, bash code has to be written as discussed in the Canvas how-to. We talked about this week 1. I'm going to stick with this for the remainder of this course, and then you're free after that. But for this course, your ifs, your whiles, your conditions, and your arithmetic have to be done exactly like we described in class, exactly like is written in the how-to, and you're not allowed to use for loops in bash. Okay? So that's just, enforcing one particular way to do things. So the quiz itself, so honor statement, just to test all of that. Let's start with question 2. So C function, named do stuff. Okay, so it's not a main program, it's just a function. It's prototyped exactly like this. Takes no arguments, returns an int. And what does it do? It prints a prompt, waits for the user to type in what hopefully is an integer, and then returns twice that integer's value. And if there's a problem with the input, it prompts again, gets another input, returns twice that value. And it keeps looping until it's got a successful input. And so examples of invalid input would be, an integer followed by other stuff, multiple things on the line, nothing at all on the line, stuff like that. Valid integers would be any of these. Okay, so you're using scanf, the way that we've been using it in class, the way we've talked about it, and then it even says down here, use fgets and scanf. All right, so so I won't flowchart this, but let's think about how we might do this. So integer do stuff. No arguments. Really weird looking curly bracket. So what is it supposed to do? It's supposed to print out a prompt. So and generally I say put a new line after a print statement because prints don't come out automatically unless you have a new line. But we're going to do an fgets which will flush this out. So we'll see the greater than sign there. Even without the new line. And then read a line of input. Alright, so print the prompt, and then accept a line of input. So how do we read input? F gets. All right, and I'll add my variables up here as I go. So I need a character array. And 120 should be big enough to type in a valid integer. But, you know, any big number is fine. But don't just make it an array like size 2 or something, because then you're limiting them to how much input they can type. So I'll do my fgets. And then we want to know if it's exactly an integer. So this is our scanf trick. So scanf. Here's the thing we want to scan. Here's the format we want to use to convert to an integer. And we're going to use that %s trick to make sure there's nothing extra. So I'll do a character extra. And I need an integer, I'm calling it num. That's the place I'm going to store the thing that I scan. And the whole way we use scanf was we looked at this return value and we made sure it was equal to 1. Okay. Again, if it's equal to 1, then we parsed an integer. If it's not equal to 1, we didn't parse an integer. Okay. So I'll go ahead and I'll save that in a variable. So I'll add that to my list of variables, return. So that's the return value. And then if that's equal to 1, then what do we return? We return twice the value of the number that we scanned, so I'll just return 2 times num. And all of these things that I've been saying while I've been writing this, these might go in comments, right? But I'm doing this longhand, so I'm not putting in comments. But you know, in particular, see if the argument that was entered is exactly an integer. And if it is, then return twice its value. And then all of this should repeat if we didn't get a valid integer. So one way to do that is throw all of this inside a while loop. And then end your function there. So that would work fine. There's lots of other ways you could do this. You could say, well, need more, and you could initialize need more to 1. And then if return was 1, you could set need more equal to 0, and that would kick you out of the while loop. And then down here you could return 2 times num. Or you could say if return equals 1 break, and then down here when you get out of the while loop you could return 2 times num. Or you could do your initial prompt in fgets, and then you could say while 1 is not equal to scanf, prompt in fgets again, and it will do that loop, and when you come out of that, you know that your scanf was correct, and you can return 2 times num. And there's lots of ways you can do this, right? Anything that works, right, gets you full credit, with a few exceptions. So let's talk about issues on this. If you did not do any looping, right, you missed a big part of the exercise, which was to be able to repeatedly ask for input and try again. So you needed to be looping. You needed to do this %s part, right, to make sure that you pick up extra stuff after the input, because we want to reject things like you know, 23.5 over here. You also need to look at the return value from here to make sure that, you know, you did get an integer. So if you just did an scanf with a %d, you're not doing any error checking. Okay, if you do an scanf with a %d and you check the return value, you're doing some error checking. You got some of those points, but you're not picking up this extra stuff at the end, right? So this was in ODPs. This was something we went over a bunch in class. So there's reference to that in videos if you want to refresh yourself. You got to use fgets, okay, to read a line of input. You can't just parse a random string. And using scanf with a %s is not the same as fgets. Okay, scanf will only read up to the first space, And so if I type in something with 10 things on the line, this loop would run through rapidly 10 times, prompting me 10 times even though I only typed in one line of input. Don't use scanf, okay? Just stay away from it. Use fgets, and then if you want to convert, use scanf. But fgets is really made to ingest an entire line up to a new line, or in this case 119 characters. Alright, so you got to check the return values from scanf correctly. When you allocate space, you've got to say how much space do I want. I'm going to read from the user and store what they type in this character array called temp. You've got to have space for that. And if you just declare car star temp, you're not setting up space. Okay, and that's probably going to segfault when you run. So if you need to have space allocated and you need temp to point to that space, this is a perfect way to do that, those two things. Set aside 120 bytes in memory and have temp point to that. Alright, if you did something like a return inside your loop, you're doing some stuff and at some point you have an unconditional return, and then you have something after that, like, you know, if such and such, that is a red flag, right? This statement is never going to execute if this is an unconditional return. Or if it's a break statement, you're never going to get to this. And so having that there, even if your program works correctly, I want to know why you put that in there, right? It suggests something is not exactly quite right. Java actually won't compile if you do this. It'll say unreachable statement, right? So that's something to think about. All right, you had to prompt. You had to use the right prompt. If you did extra output, I did not take off points this time, but it doesn't say anything about printing anything except this greater than followed by a space. So if you print the return value before you return, I didn't take off points, but that's really not something you want to do. That would be like calling the square root function to calculate a square root, but it also prints out the value of the square root. Well, you know, it's your program. Maybe you don't want something printed in the middle of this calculation. So don't generate output unless it asks for it. If you did a recursive approach to this, recursion will blow up after too many times, and if I put in 1,000,000 bad entries, my recursive solution would blow up. If you don't know recursion, don't worry about that. That was just a couple of people. And I dinged 1 point if you did a single equal sign instead of 2 equals, just because that's what I call the hardest error to find in C. Any chance to break that possibility is good. Always use 2 equal signs for comparisons. Modern languages will tell you about that, but C just lets you do it. So if I do a single equal sign, that changes the value of return to 1, and then this will return even if I had an error in my input. All right, let's go on to question 3. And as I mentioned in the last class, when I wrote the exam, I called this question 0, I called this question 1, I called the last thing questions 5 through 9. But for some reason, when the quiz pops up, it numbers these things sequentially and ignores the titles that I put on the questions. So that's why the numbering was a little goofy at the end there. So, so in my comments to you, the question I refer to is the question as it's numbered in the quiz. So this is actually question 3, even though it's only the second question. We got 3 minutes. Let's start this. Write a C program that accepts 2 command line arguments, prints the sum of all integers between them. So you're going to run your program with, you know, let's say the program is called Q326. What should it do? It should calculate 2 plus 3 plus 4 plus 5 plus 6, and it should print out the sum, which is 20. Okay, that's your desired behavior. And you print an error message and exit if any of the following things happen. If there's not exactly 2 arguments, or if either argument is not exactly an integer, or if the first number is not less than the second. So if I say Q3 haha, print an error message. If I say Q3 2610, print an error message. If I say Q3 6.0, print an error message. If I say Q3 76 or 66, print an error message. Okay? We only have to do this summation if everything is totally precisely correct, meaning exactly two arguments. They're both exactly integers, and the first is less than the second. So our usual startup there. What's the first thing we do? If argc is not 3, I'm just going to call an error function. The error function will print a message and do an exit. But you know, I could do curly bracket, print an error message, and then say return. But I'll save myself some writing on paper here. So if argc is not 3, print an error message, exit. If 1 is not equals to scanf, argv bracket 1, %d, %s, address num1, extra, print an error message and exit. If I get through here, my first argument, argv bracket 1, is a valid integer. Do the same thing with bracket 2. If I get through here, my second argument is a valid integer. If num1 is greater than or equal to num2, print an error message and exit. If I get down here, I'm good to go. Alright, so now we calculate a running sum. We'll start with that tomorrow, and then we'll talk about gotchas on this assignment. But that's the basic setup. Alright, so we'll continue that tomorrow. Alright, have a good afternoon. I will see you next time.